We wanted to talk about the topic of image inpainting. The copyright of the pictures and sightings shown in this video are adapted from the following sources. Image inpainting is an ancient subject. It has existed in ancient time. For some damaged images, artists use their imagination to artificially fill them, just like the falling to oil paintings, to fill in the missing information in these images. Apart from that, image inpainting can be used in photo restoration. You can see in these pictures, the wrinkles in the pictures are all removed. Also, it can be used in object removal. In this picture, a person is removed and the missing information in the left picture are filled by the information around. Also in the right picture, you can hardly imagine that there used to be a person. In our video, we will mainly introduce three algorithms to give you a basic understanding of image inpainting in the modern computation.
Image inpainting based on partial differential equation is widely used in the field of image processing due to its advantages of high flexibility and anisotropy. Image inpainting based on PDE is a process of automatically recovering unknown information based on the existing limited information. The type of the algorithm can be divided into texture-based and structure-based. We mainly discuss the latter one in the following parts. This type of algorithm have two classical methods, includes TV methods and the CDD methods. First of all, allow me briefly introduce the principle of image inpainting. The PDS operates in much the same way that chain restorers do. They propagate information from the structure around the hole into the hole to fit in. There is an image R, and the omega region need to be fixed. We could fill in the missing information area omega from the geometry and the luminosity information around the area. Sometimes it just needs information about a band-limited region B around omega. The first model I will introduce is total variation model. The TV-based image inpainting method can be used for the restoration of images with disturbance. In order to cooperate with the integral from the variational process to the boundary, the boundary condition along partial omega must be a partial boundary condition. Partial omega divide partial vector, where vector is a normal vector to the boundary. This repair method will extend the sharp edge to the repair area omega. This method has some drawbacks. The first one is TV interpolation is the linear interpolation. Corners may be generated along the repair boundary. The second one is there are deficiencies in the repair of larger and wider areas. The second model is curvature-driven diffusion model. The CDD-based image restoration method introduces the curvature term on the premise of improving the TV repair model. In the TV method, there is usually a large corner and a large curvature, where cannot be continuous repair. A large curvature can effectively extend some information along the boundary, and the CDD method makes use of this to make the diffusion along the vertical direction of the edge stronger than the direction of the parallel repair edge in the process, so as to realize the continuous repair of the longer area. Then this is the result of two methods. As it shows, the original image is a standard linear image with 512 pixels multiplied by 512 pixels. The B picture is damaged one. Then C and D are the inpainting results of TV method and CDD method. We can see that both methods basically fix the image as it is, but there are still some unrepaired areas. This means that both methods still need to be improved.
Now imagine a scene. You just want to take a picture of the beautiful scenery, but your girlfriend asks you to take a picture of her. Now you want to remove her, like this. The second one is what you really want. How can you do that? We have an image inpainting technique to remove object from the image, which is better than the magic of Harry Potter. There are usually two ways to remove the large objects from the digital images. They are texture synthesis and inpainting techniques. However, texture synthesis is difficult to avoid the spatial interaction of the texture, and inpainting techniques is not very good when the algorithm apply to fill large regions. We will introduce another image inpainting technique, the exemplar-based inpainting, which combines those two techniques, made up for the disadvantages of those two techniques. Next, we will analyze the principle of the algorithm. The principle actually is a grading algorithm, always looking for the best solution in the process. The image can be divided into two regions, the target region and the source region. Inpainting will start from the boundary of the target region, the square template which is centered at the point P, which you can see in the figure B. Then find a most similar symbol in the source region, like the percent Q in the figure C. Then to fill the square template, percent P, which has been chosen already. We can split the algorithm into three steps. Step 1. Computing patch priorities. From the two components of this formula, CP is the confidence term. When filling, the surrounding pixels with more information will be filled firstly, because they are surrounded by more pixels in the original images. They can provide more reliable information. DP is data term, shows that pixels near original image structure will be filled at first, so the original structure of the image can be better extended towards to the hues. Step 2. Search and pass the best match sample percent Q. Simply calculate the sum of the squared difference of percent P and percent Q, then pass this sample percent Q to the target region. Now, first inpainting has already been completed. At last, continue to update the confidence term and the formula. But this algorithm has a considerable drawback. If the image does have a property sample without much information, this algorithm will not work very well. Let's see the result of the algorithm. So, how to despair your girlfriend? The algorithm always found the best sample on the boundary until all the target region are filled. Also, you can despair your boyfriend like this.
We have introduced the two traditional algorithms, and both of them are based on mathematical method. However, traditional methods have the following two drawbacks. First of all, traditional methods can only use the information of the existing area to fill unknown area, but they will not do any prediction. Second, When the scale changes, such as rotation, the computational complexity increases drastically. Deep learning algorithm can solve those two problems, and the model will learn from the data and add prior information to the algorithm and then do prediction. Here I want to introduce an algorithm called context encoder, which is composed in 2016, published in CVPR. The context encoder uses CNN, which is a convolutional neural network, as a self-encoder machine to extract the feature and do prediction. We can see in the following picture, in the procedure of encoding, the feature of a picture with size of 128 times 128 are extracted using CNN kernels and generate a vector of 4,000 features. And in the decoder procedure, the features are recovered by kernels to generate the content in the blank area. And you can see in the lower part of the picture generated in CNN are put in a GAN. GAN is generative adversarial networks. So what is the use of GAN? Actually, you can just consider the GAN is to make the result better. After having a basic concept of the architecture, I will show you how does the network works. When we are training the model, we should input data like those in the left part. A picture with blank area as feature and the missing content as label. We should put lots of data like those picture pairs to train our model. Usually, when we want to train our model, we have to define a loss function to see our error between our prediction and the correct answer. Here we use L2 loss function, also acknowledged as mean squared error. However, L2 is not enough. GAN will help to make our model better. What is GAN? You can see here, GAN is also like CNN. However, it has a little different. In GAN, we import the picture in the blank area with label 1 and our prediction with label 0. So the GAN, if we can't tell a picture that is label 1 or label 0, our GAN will reach the best. In other words, given a picture, the best situation is that we can't tell whether it is from the prediction or from the real picture. In the red part, you can see the loss function. Usually, in machine learning models, we want to minimize the loss function. However, in GAN, we want to maximize the loss function. In real situations, we use L2 function and GAN together to do optimization. After training the model, we can use it to do prediction. And this procedure is easy. We just put the picture we want to input, and the model will do prediction and give us a complete picture. Look at the picture. It is from the original paper. We can see the model generates new things that is never seen from the original ones, like the crab and the buildings. So it's all about our presentation, and thanks for watching.